Let's consider three different methods of solving the same quadratic equation. So our goal is to solve x squared minus x minus 20 is equal to 0. So the first and simplest method for this problem is to solve by factoring. So when solving by factoring for one like this that has a leading coefficient of 1, we think about two numbers we know that multiply to negative 20 and that add to negative 1. So we're looking at the number at the end for our multiply and the number in the middle as our add. We have to work a little bit harder if there's a leading coefficient other than 1, but this is our simplest case. So two numbers that multiply to negative 20 and add to negative 1, we could use negative 5 and positive 4. So our factors will be x minus 5 times x plus 4 is equal to 0. To check, we can always multiply these back out, make sure it matches our original equation, and then set each factor equal to 0. So we end up with two solutions, x equals 5 and x equals negative 4. So now let's look at another method just to see how the others work as well. So as a second option, let's look at how we could solve this by completing the square. So when we're completing the square, the first thing that we're going to do is move our constant term over to the right-hand side. So I'm going to rewrite my equation as x squared minus x is equal to now positive 20. So now we look at the number in front of the x term. In this case, it's a negative 1. We want to take this value, divide by 2, and then square that. So negative 1 divided by 2 is negative 1/2. And then we want to square negative 1/2, which gives us a positive 1/4. So this means positive 1/4 is the value that we want to add on the left and on the right-hand side of our equation. The left-hand side can now be factored as a perfect square. In completing the square, the first term in our factored form will always be an x. The second term will always be whatever we had when we took half of that middle term. So in this case, minus 1/2. You can check x minus 1/2 times x minus 1/2 will really give us x squared minus x plus 1/4. On the right-hand side, we want to add the 20 and the 1/4 and write this as an improper fraction. So we do not want any mixed numbers or decimals. So using our calculator, this turns out to be 81/4. So now that we have this written as a quantity squared is equal to just a constant, now we can use the square root property. So I'm going to take the square root of this side and set it equal to plus or minus the square root of 81/4. When you take the square root of a quantity squared, those cancel each other out and leave just x minus 1/2. We have plus or minus. 81 is a perfect square. The square root of 81 is 9. 4 is also a perfect square. The square root of 4 is 2. So we're left with x minus 1/2 is plus or minus 9/2. Solving for x, so adding 1/2, we have x is equal to 1/2 plus or minus 9/2. So this is really giving us two solutions. X is equal to 1/2 plus 9/2, or x is equal to 1/2 minus 9/2. So adding here, we have 10/2, which is equal to 5. Here we have negative 8/2, which is equal to negative 4. Notice these are the same solutions that we got when we used our method of factoring as well. So now for a third option, let's look at using the quadratic formula. So both completing the square and the quadratic formula will work on every single quadratic equation. Those methods will always work. Factoring will work on some equations, but not on others. So not all equations can be solved by factoring, but if factoring will work, it's usually our easiest strategy. So our quadratic formula actually comes from the process of completing the squares where this formula was derived. We get that the solutions will be of the form x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So the a, b, and c here refer to our standard form ax squared plus bx plus c equals 0 for a quadratic equation. So that means for our equation, a is equal to 1, b is equal to negative 1, and c is equal to negative 20. So we want to plug these values into our formula. So x is equal to the opposite of negative 1, which is positive 1, plus or minus the square root of negative 1 squared, parentheses are important there, minus 4 times a, which is 1, times c, which is negative 20, all over 2 times a, so 2 times 1. So simplifying underneath the radical here, negative 1 squared is positive 1, minus 4 times 1 times negative 20 is plus 80, so we have the square root of 81 all over 2. Since the square root of 81 is a perfect square, we can simplify that to be just 9 all over 2. Again, this is giving us two solutions, 1 plus 9 all over 2 and 1 minus 9 all over 2. So 10 over 2 gives us 5, 1 minus 9, negative 8 over 2 gives us negative 4. So same solution, but three different methods of solving the same quadratic equation.